I've been coding professionally for more than 15 years, and let me be honest, I had my fair share of bad decisions and questionable architecture choices. So much so that after all this time, I strongly believe that the only valid advice in programming is to always keep it simple. Avoid over-engineering and run away from premature optimizations. For a long while, I called all this unnecessary complexity, but I recently ran into an article that does an excellent job of explaining the pain points of complexity as cognitive load. In practice, there is a reason you understand this statement at a glance, while you would have to jump around the code base to learn what all these magic numbers actually mean. Or this is why concepts like composition over inheritance save your sanity in the long run. Instead of climbing up and down an endless class hierarchy, trying to figure out which method does what and where it's overridden, you work with smaller, clearer building blocks that do one thing well. It's less mental bookkeeping and more time spent actually solving the problem. And, believe it or not, this is why experienced programmers will actually break principles like don't repeat yourself for the sake of keeping the code easier to follow. A few extra lines that are explicit and self-contained can often do wonders for readability. After all, Rob Pike, one of the creators of Go, put it best. A little copying is better than a little dependency. And this is why I have thousands of duplicated lines in my project. And this is why I always look at every so-called best practice with suspicion. For instance, I've seen teams implementing a state manager, actions, reducers, selectors, and all sorts of boilerplate just to handle something that could have been a simple fetch call and a DOM update. So my main priority is really straightforward these days. I want to write code that makes it easier for the next person to make changes without wasting hours just figuring out where things are and how they connect. Because there were many times when I was frustrated with some piece of garbage code, only to find out it was written by me 6 months ago. Back to cognitive loading, the reality is that there's only so much our brains can hold at once. Once you hit that limit, every extra detail you need to keep in your head pushes something else out, and that's when mistakes happen. It's also worth mentioning that cognitive load can be intrinsic when the inherent difficulty of a task causes it, or it can be artificially created by the way we choose to structure and present information in our code. And, while the intrinsic cognitive load of a problem can't be reduced, that artificial complexity is entirely within our control. So, let's look at some practical examples. The first thing we can do is to choose the right tools for the job. Take a look at this Java method and tell me what all these parameters do. Of course, you would have no idea, and things will get even more complex if the method definition is overloaded with even more variations. In a more modern language like Kotlin, you could avoid all the method overloading with default parameters, and you could remove all the cognitive load brought by these ambiguous method calls with name parameters. All of a sudden, you can fully understand the method call at a glance, instead of being forced to jump through files and remember variable names. So, while Java is one of the most popular programming languages in the world, and it is used in high-risk, high-complexity environments, like banking systems and enterprise at scale, it forces developers to add unnecessary cognitive load. And, to avoid this complexity and make life easier for the next person reading your code, people came up with design patterns like builder objects, which allow you to reduce code reading complexity by increasing code writing complexity. So, in languages that don't offer conveniences like named parameters, patterns such as these ones are considered good practice because it makes code easier to read. But these best practices are actually adding artificial cognitive load because they are born out of necessity to address programming language limitations, not to solve a real problem. So I would argue that there are instances when good developers will ignore what some call best practices because they are aware of the long-term implications of such decisions. But let's say you are lucky enough to work in a programming language actually designed by sane people. Well, in this case, there are a few small things you could do to drastically reduce cognitive load. I already mentioned things like magic numbers and why replacing them with descriptive constants or enums instantly makes code more readable. The same goes for replacing cryptic status codes with self-describing strings, because nobody should have to keep a mental dictionary just to figure out what 418 means in your system. Another easy win is flattening deeply nested conditionals. If you have an if statement inside another if statement, you are forcing the reader to mentally track every precondition before they can even reach the actual logic. Early returns let you drop those conditions as soon as they fail, freeing up working memory for the code that actually matters. You can take this even further with how you name things. Good naming eliminates the need for extra comments or mental translation. If you name a variable is allowed to publish, no one has to guess what allowed means. If a function is called calculate invoice total with tax, you don't have to open it to figure out what it does. The goal is that a new developer should be able to follow your code like reading plain English. And finally, resist the temptation to introduce patterns, layers, or abstractions if you don't really need them. If you don't have a real problem to solve, you're only making the code harder to follow for a hypothetical benefit that might never come. The best systems I've worked on weren't the ones with the most patterns, the fanciest architecture diagrams, or the trendiest stack. They were the ones where you could open the project for the first time, follow the flow of logic without asking anyone for help, and make a change on your first day without fear of breaking something you don't understand. So, the bottom line is simple. Write code that is boring, make it obvious, and choose clarity over cleverness. And since simplicity is so valuable in software development, you should check out today's sponsor. Sevala is an all-in-one, no-friction platform as a service for deploying anything ranging from interactive apps to databases or static sites, offering cloud-native performance and a seamless dev experience with advanced deployment pipelines, instant preview for apps or static websites, and one-click deploy templates to accelerate your development process. Under the hood, Sevala is leveraging Google Kubernetes Engine across 25 regions, and thanks to Cloudflare's Edge network integration, your static content is globally optimized for speed. Check out the link in the description and you can get started for free with a $50 credit, no hidden fees and predictable payments.